Good day, viewers. You all welcome to today's edition, which is another episode of standard derivatives. Okay, standard derivatives. And in my last video, I made it known to you guys that we are going to look at the derivative of y equals to sin x, derivative of y equals to cos x, derivative of y equals to e of x, which is an exponential function of x. All right. And in that same video, I also showed you guys that if we take the limiting value of sine theta over theta, we are going to as theta approaches 0, we will obtain 1. Okay, so if you are new to this channel, this is Mathematics Clinic by Tutor Chris. And if you haven't subscribed to my channel, kindly go ahead and do that now, and I promise you will never regret that. Okay, all right, let's move on to today's course now. So we're having y equals to cos x. Okay, now in that last video which I made, I also let you guys know that y is a dependent variable which depend on the value of x, okay, and I said x is an independent variable because if there's little change in x, there are also that will add a little change to y. Okay, so now this is what I'm trying to say now. That is, if I add a little change, that is y plus change in y equals to cos into bracket over x plus change in x. No, if there's a little change in x, also there will be a little change in y. So that's why I'm having plus the y. Okay, now this is something else. That is, if I subtract y from both sides, this means I'm having the y equals to cos over x plus the x minus y. You know why I have to subtract y from both sides? Because I'm looking for the derivative of this function. Okay, and what do I mean by derivative? That is change in y over change in x. That's what I mean by derivative. Okay, so I'm looking for a way in where this left hand side will be left with the y. Okay, so I'll be looking for a way to also have the y over the x. I hope you get that now. Oh my god, that's just a trick. I hope you get the concept now. All right, so that means I will be having the y equals to cos over x plus the x, and you know from this function we're having y equals to cos of x. Don't forget that. So this y will change to minus cos x. Okay, this is beautiful. All right, so we're having our dy to be equals to cos of x plus the x minus cos x. This is wonderful. All right, you know, when I get to this direction, when I get to this area, I make use of the trigonometry identity. That's very useful in calculus. Okay, and in that last video we're having sine of x plus the x minus sine x. So I make use of the half angle over sine. Okay, now but instead of that I'm having cos now. Okay, I'll still go back to that trigonometry identity. Sorry for that. Trigonometry identity. Okay, so that means I'll be having don't forget the trigonometry identity for cos a minus b. Cos a minus b equals to that will give us, according to the trigonometry identity, so we are going to have a negative 2 sine a plus b divided by 2. Okay, dot sine a minus b over 2. Okay, all right, so this is the value for cos a minus b when we are dealing with trigonometry and making use of the trigonometry identity. Don't forget this is also cos of x plus the x minus this. You can see they are in the same form. Okay, now where my a is serving as x plus the x, as we did in that last video. If you haven't watched that last video, you are missing a lot. Kindly go and check my videos now and make sure you watch it. Okay, all right? So now we're having a equals to x plus the x, and my b will be the value of x, the value attached to this cos here, okay, and that's x. All right, so what am I going to do now? I'll just come back to my dy here, which is cos of this. Okay, don't forget I already said that cos of a minus b, that is this form. I'm gonna write this to be dy equals to, so now instead of that I will be having minus 2 sine over a. Our a is x plus dx, don't forget, all divided by 2, okay, dot sine over a minus b. Our a is x plus dx, all right, minus b, which is x, all divided by 2. All right, this is beautiful. Oh my god, I hope you guys are getting the concept. All right, let's move on now. So I'm having this, and if you look at this, I can apply some algebra sense to this. That is, this is same thing as negative sine over. Okay, before moving on to this, let me quickly show you this before moving on to this. All right, before moving on to this, okay, before moving on to this, I'm having the y. Let me clear what I'm having inside the brackets first, okay? Don't be in a hurry. So I'm having minus 2 into this. This is oh, there's a mistake here. You know, we're having a plus b. I only wrote for a, so we're having plus x here. I hope you get that, plus x here. Sorry for that. So I'm having x plus dx plus x, okay, and x plus x, I'm going to obtain 2x plus dx, all divided by 2. Please, I'm so sorry for that. Okay, now this is sine x. We cancel x, positive minus positive x minus x, that's 0. So I'm going to have dx over 2. That's beautiful. Now I'm having dy equals to this. I can apply some okay, I can apply some algebra sense to this. So this is same thing as minus sine over 2x. Okay, you know, 2x divided by 2, I'm going to have x. All right, 2x divided by 2, I'm going to have x. You know, 2x is 2 is standing as what? The numerator in this 2 is standing as the numerator here. So if we divide 2x by 2, I'm going to have x here, don't forget, plus dx all over 2. Okay, and this is sine over, you know, you can rewrite this also. We can break the 2 here to be 2 sine dx over 2. Okay, you know, this is just normal algebra sense. That is, if you multiply, you know, we're having negative this multiplied by this. If you multiply them again, you are going to have, if you multiply this with this, you are going to have what you are going to obtain here. Okay, that's simple. I've not done something magical there. So now I'm having the y equals to negative sine over x plus dx over 2. Okay, dot 2 sine dx over 2. All right, now do you know what I will be doing now is that I'll divide both sides by dx. And why am I dividing by dx? Because we are looking for the derivative of this the function that is y equals to cos x. I know I told you guys that derivative means changing y over changing x, so that's why I want to divide both sides by changing x. Okay, this also divided by changing x. Please, I'm so sorry for the line, don't mind me. Okay, so I'm having dx. Oh my god. Now let's continue with our work. So I'm having the y dx at the left hand side equals to negative sine x plus dx over 2. Okay, I can say this is multiplied by this 2 sine dx over 2, all being divided by dx. No, if you multiply this with this, you are still going to have this back. Okay, look at it very very good. Pause the video and try what I'm trying to say. Okay, if you multiply minus sine of x plus dx over 2 multiplied by 2 sine dx over 2 over dx, you are still going to have what we have here. So I've not done something tangible. It's just a little application of the algebraic sense. Okay, Now let's continue. So I'm having the y over the x equals to negative sine of x plus the x over 2. Okay, now this I can also apply another sense of algebra to this. That is, I can divide the numerator here with 2 and this denominator, and if I do that, 2 is going to cancel out, so I'm going to have a sine over the x over 2 all over the x over 2. Okay, my viewers, what should be your problem now? I mean, what should be your question now is that why am I dividing the numerator here by 2 and the denominator by 2? Okay, I'm doing that in order to eradicate these two and also to obtain something in form of this. I already said that if you take the limiting value of sine theta over theta as theta approaches 0, that is going to give us 1. Okay, that's the reason I did this now. Okay, that is, let's say this is serving as theta over theta, and that's going to be, if you take the limit of the x now, this will give us 1. You get what I'm trying to say? Okay, that's what I'm trying to look for. I have to set this up. Okay, so now the y dx, the limit as the x approaches 0, okay, of the y dx equals to negative sine x plus if we take the limit of dx over 2 now, that's going to be 0 plus 0 plus and if we take the limit here, that's 1. Okay, don't forget the limit of sine theta over theta as theta approaches 0 is going to give us 1. So if we take the limit of the x now, this will approach 1. Okay, so now this means that by the y dx is equals to negative sine that is this is x plus 0, which is same thing as x plus 0 is going to give us x, so minus sine multiplied by x. Now I'm having negative sine x. Okay, this is variable dot 1, and this is going to give me, that is 1 multiplied by any number is still going to give you that number, so I'm having negative sine x. Oh my god, and this is our destination. So that now tell us that the derivative of cos x is negative sine x. In my last video I also showed that the derivative of sine x is cos x. Okay, alright, so I'll be stopping here today, and my next video will continue with the derivative of exponential function, that is the e of x. Okay, alright, don't forget, this is Mathematics Clinic by Tutor Chris, and if you like any of my videos, kindly subscribe, invite your friends, share it with them, so whenever I upload a video, they will also be here to enjoy. Okay, thank you, see you next time, bye bye.